Yes. So now we have to discuss sigma bonds or the both type of bonds, sigma and pi bond in details. So sigma bonds are generally stronger because they have linear overlapping and they have more ratio of overlapping than pi bond. That's why they are more stronger. They have low energy and more energy is released and reactivity is also low. That's why they are stable. Single bond is always sigma bond, and the first bond in any atoms or in any bonding of molecules is sigma bond. Overlapping along the bond axis is also called sigma bonding. Here we can see all that. There are three types of more types of sigma bonding: SS, SP, and PP are the types. Here we can see the structure or the diagram of the sigma bonding. So you can take H, for example, we have H, okay, where which is 1s and 1s. So an orbital of 1s plus 1s, like we have both over here, okay, this and this. Now they both combine and they overlapped over here and become 1s2, and their electronic configuration has got stable. So this is the sigma bond. Uh, they are pure. They can be pure bond like this, but they can be from hybridized atom. We know that we have hybridized atom, which I will also explain in another video. They are strong. They have high bond energy, which means the high bond energy released, and they have now less bond energy. Can exist independently, and can impact on shape of molecule. They impact on shape of molecule. Now discussing the main points of pi bond. Pi bonds are generally weaker. They need a sigma bond. First of all, as we can't have we have a pi bond in P. Okay, so first of all, we need PX, PX, PY, PY, and PZ is like this. Okay, PZ. First of all, these XX will make bond. The PX and PX will make the sigma bond. Then after that, this and this will make bond. Like this one and this one will make bond. So they cannot exist independently, means they need a sigma bond before they are made. So cannot be or like cannot be made independently. The probability of finding electrons in pi bond is generally over here, above the bond axis or below the bond axis, okay? Because they both combine over here. So the probability of finding it over here, not here, okay? They are perpendicular to the bond axis. Yes, they are perpendicular to the bond axis. Bond axis is like this, and they are like this, okay? Overlapping, lateral or parallel, or you can also call it parallel, lateral, or sideway overlapping because they are overlapped from their sides rather than from their heads. Okay, Py and Pz do make pi bonds. Okay, they are hybridized atom. Like they cannot be of hybridized atom because you know that hybridized atoms are only from S or sometimes from Px. We don't go so much for Py and either. So they are usually made from unhybridized atom because unhybridized atoms always go in X. They are weak, exist along with pi bond, sigma bond. They cannot exist independently. No role in determining the shape of molecule. They don't play any role in determining shape of the molecule. So thank you. So now, how to identify number of sigma and pi bonds in an atom? So actually, first of all, the first step is to check that the for always the bonds of the atom. For example, you have H2O, okay? H2O. Draw an H2O and now check how many bonds do we have. First, like O with H and O with H, okay? So first bond is always sigma. Remember that we got two bonds over here, okay? First is almost high. You can check that this one is S. We know that this has one S, and we are going it with 2p, I think, 3p or 2p something. Okay, so it will be S and P. So here SP combining, which means it's sigma. Here SP combining, which means sigma. And the second and third is always pi. Okay, remember this. Up now, here we have C2H4, which is ethene. Okay, so first of all, here this guideline is basically for the covalent bond. Okay, we have covalent bond of three types. Okay, three type: single bond, double bond, and triple bond. So always remember that the first type of bond, which is single bond, will always exist in sigma. Okay, we have CH4, the C. Sorry, sorry, sorry. We have C2H6. Okay, so that will be a single bond between carbon and carbon. So it will be sigma. But here you can see one sigma, one pi. Like it is stated so true that if you have three, so इसमें एक sigma, दो pi. Okay. Now check. Carbon has P, H has one. So Sp, it has S, it has P, Sp, Sp, Sp. So no, sorry, 5 Sp, because we have one sigma over here, so 5 sigma, and and the two are 1 pi. Here as we have the C3H2. So C3 1 sigma, 2 pi, the second and third is pi, 1 Sp pi, 1 Sp pi. So I hope you would have understand this, how that we have done all this stuff.